This is an audio test.
So, good. Welcome everybody to today's .NET meetup. Thank you all for joining here in the location at Rubicon and all the people on the stream. We are live. This meetup is organized by .NET Devs.at. We are a non-profit organization. It's all about sharing knowledge and experience about .NET technologies. We are Carl in this corner and Stefan who makes pictures there, and Martin who isn't here, and me, Annie. We have a website, we have Twitter, we have Twitch, we have a YouTube channel, we have a Slack channel. Probably heard about it already. I want to thank our sponsors, especially today Rubicon for this awesome location and food and drinks and everything. Thank you for being location sponsor today and also sponsoring us financial, that we can do also this streaming and recording of the sessions for later. And also thanks to G8 also sponsors us. Also thanks to JetBrains, they are sponsoring a 12-month product license that we raffle, and we will raffle this today here in location. Sorry, stream next time. It's your time again. And with that, some quick news from the community. We are part of the .NET Foundation, and they run this .NET virtual user group where a lot of different other user groups post and announce their meetups. So if you need more .NET content, there you can find it from all over the world. And the second, our Stefan is streaming every day on Sundays, 9 to 11, Central European summertime at Twitch TV, Leisureware, and currently he said it's a niche, it's performance benchmarking of source generators. I wouldn't say it's niche, but yeah, so if you have time, join them into the streams, it's pretty sure it will be fun. And with that, I'm done, and I hand over to the ILSpy team today for Ask Me Anything. And we need a moment to switch here, so could be some technical difficulties for the stream. Give us a moment. So, on screen sharing. But the monitor build is like, it's the beam of build is like exactly. So the duplicate and duplicate. So, screenshot on the screen.
Yeah, perfect. So a warm welcome from us, the ILSpy team. We have 3 names on here, but it's only 2 of us, thanks to the various flight cancellations. One of our team members is just right up in the air at this moment, coming to Vienna. So you have to do with the 2 of us. My name is Christoph, this is Daniel. I'm going to do the more non-technical information. He knows all about the implementation stuff. Yes, yes, oh, sorry, yeah, got that wrong. So, yeah, thinking about the different things. So we kind of had a run lately. Well, not a run. We are now officially part of Roslyn. an official decompilation solution, because for a very, very long time, we have been behind the feature flag. Now, these days, we are actually part of Roslyn, and also with Visual Studio, the most recent versions, actually on by default. So if you press F12 in Visual Studio, and you don't have a source for this, like either on Nougat or somewhere else, our compiler will keep being by default. So that has happened since the last time around. And kind of, we also were a recipient from the Microsoft OSS Fund for a kind of stipend, we would say, because Microsoft employees get to vote on open source projects they want the OSS Fund to support, and we were one of those recipients recently for this. So we were very happy that we received that. So a recap is necessary. We've been here already, and the last time we've been here was in December of 2017. And we are never always perfect with our predictions, and we want to be open upfront. What panned out properly over the past few years, what didn't, what fell flat on its face. So kind of being upfront and honest, what worked, what didn't. So the topic last time around was, we have this great .NET Framework application. We want to move the decompilation engine to .NET Standard and actually use it properly. And that was a very, very convoluted technical experience, to say the least, and that was what we were talking about last time around. Today, to recap, those are actual screenshots from the past slides, is yes, this obviously worked perfectly fine. We retargeted to .NET Standard 2.0. Basically, we are using the modern CSProc files. Basically, this slide was spot on. That was okay. And the next one is already a little bit so-so. So what worked perfectly fine, we still have the console app. The console app is not actually a full-blown .NET tool. The PowerShell commandlets haven't seen any changes or improvements. Those are basically still there, but aren't being used. The workbook is still there. It's now a .NET workbook. It's still kind of to see, and the first one and the last one. Those are the ones that we are going to revisit also today, because those actually weren't so smart decisions after all. As well as this slide, which is kind of embarrassing in retrospect, but actually, to be honest about it, we said back then we're not going to care about any other frameworks but WPF. Turns out somebody else did, and ported our ILSpy to Avalonia and made it available on Mac and Linux. And then kind of transferred it to our organization. So we now own the code base for this cross-platform UI. So that didn't age well at all. What also didn't age well is like SAM standard that never went anywhere, where we were kind of hoping that this might help us bridge the gap for different platforms. That didn't happen at all. So that didn't age well. So what has happened since? Well, the challenges to .NET 6. I decided to put this in so that there's no misunderstanding. The Decompiler engine itself is .NET Standard 2.0 and will remain .NET Standard 2.0. The reason being is Roslyn is .NET Standard 2.0, so to be part of Roslyn, we have to stick with this. And there are also other consumers, because we are not only in Roslyn, in Visual Studio, in Visual Studio Code, we are also in LinkPad and other products. So those products also have down-level framework targets, so we need to keep this down-level framework target for us. So this is a hard limitation, which means limitations for the language features we can use ourselves in the Decompiler. So that's a downside for us very specifically. We can't use the latest and greatest in those parts. However, we can take the WPF frontend and make the WPF frontend .NET 6. Because the .NET tool was already .NET Core, but we kind of only moved this from 3.1 to 6.0. So that's why we had WPF and then everything below to say everything is now .NET 6. So how did we go about it? Well, the first thing was, okay, let's do a super dirty trial and simply replace net 472 with net 500 back in the day and see what happens. Does F5 actually start the application? Turns out it didn't. Well, quite unsurprisingly, it didn't, but the problems were rather minor. So we decided to kind of build a bridge to actually allow people to target this. The reason why we didn't officially support it was we have ILSpy in the Microsoft Store. And for the Microsoft Store, back in the day, you needed an installer project for MSIX. Those guys don't like multi-targeting. So that's why we kind of were like, okay, we can't do it now. If you want to try it, you need to kind of use only one target. And we're going to provide you with the necessary trickery. And here is the 2 or 3 steps. Now, this was done. So basically, we knew we could go .NET Core if we wanted to, but we had to kind of wait for all the other pieces to fall in place, like Win32 app support in Microsoft Store. So we could get away from the MSIX and go to a proper Windows installer again. So this was what we did. We kind of merged this and never really talked about it except for this kind of line here, building for ILSpy 5 is also possible. Well, turns out someone took up the challenge and kind of ran with it and built it on ARM64 already back then. So this wasn't really something that we were expecting, that somebody would immediately take it to ARM64, but they not only did .NET 5, but already .NET 6 during the beta phase. So yes, they built it, and kind of gave us the information that this wasn't so hard. So that was really the intention of the entire story, to prove out that it works and kind of have the ability to play around. So this was one step on the road, .NET 6 for us. Now, we had, as I said, .NET Standard, we have the .NET tool, which meant we were already capable of running on Mac and Linux back at this point, even though the WPF frontend was .NET Framework and Windows only. But we already had the stuff running on Linux and on Mac. So we kind of ran into all those nice problems you get when you run cross-platform. And I only picked a few of those here to give you an idea what could go wrong, the classic directory separator, etc. So we kind of ran into those again and again, like kind of looking at open link for .NET 6. Oh, you see that the next change is traced using a bug listeners. And we kind of started adding information in here for ourselves, which sadly we didn't really actually look at up until today, is we have instrumentation about the performance in our decompilation engine to see when we move from 4.7.2 to 6.0, does performance improve actually? How much do we gain for free when moving to 6.0? That's why we added performance counters in there. So that I wanted to point out. That's a nice way of proving to yourselves that you actually get a performance improvement for free. And adding those DW instrumentation information, that's super easy. Okay, that's too bad. Can you move the string a bit to the side? And then we delivered 7.2.1, especially for one thing, again, cross-platform, but we needed a Win32 registry for long path support. If you want to be bored to death and spend 4 hours here in this room, ask him about it. I guarantee that's a long one. Okay, so that's kind of the things that happen in between. And these are not working. That is nasty. Can you find this? So then we actually went a step further and kind of decided to go to the .NET 6 SDK. So this was a minor step, basically, but we are very conservative when it comes to expecting our users and contributors to be on the latest stuff. We try not to do that, so that you don't have to have the latest bits and pieces. That's what we try to avoid. But it actually happened, so we went to .NET 6. And yes, the next step obviously was to actually do it, to actually move it. And the first thing that happened, the multi-targeting code went bye-bye. So we no longer needed it. We decided to go Net 6.0 only, nothing else. Obviously, we could delete a lot of if statements in our code base, which made this at least easier. Very much the first thing that went away was the MSIX project. We already had the Wix-Sharp base project, so if you ever build a MSI installer, that's a great way of building it, actually, because that's super easy. C# code builds as part of the pipelines. That's rather nice. And all smaller, minor things. That was the easy part. But there's obviously more to it. And yes, we had like project format. I think if you look close enough in our source code and in our projects, you will still find weirdness in our project files. That's because we hacked the project files as part of the last time's presentation so much that we needed to get this basically done. So what tripped us up? What tripped us up, really? Our tests. For most developers, I don't have tests, cool. Yes, for us, we have tons of tests. The main time issue we have with our builds, I think the debug builds run something like 35 minutes, is like at least 25 is the tests, at least. So the reason being, we are testing a lot of different variations, obviously, because .NET isn't homogeneous. .NET is actually multiple runtimes if you look back in history. Yes, Silverlight. Yes, one of them. .GNU isn't a thing, not really. We haven't seen such binaries really, but we have the newer line of core frameworks. We have the older line of .NET 4 frameworks. We have different compiler versions, like the old CSC native compilers, the newer Roslyn compilers, all different versions, MCS from Mono guys. We need to build with optimizations on, with optimizations off. We need to kind of do checks with nullable enabled or not enabled. This means there's a whole bunch of stuff that's going on, plus a very special one that cost us a lot of time, the correctness tests. Where we, yes, we agreed we will simplify it here on the slides because it's not exactly the order it happens in, but it basically is take a C# file, build it, run it, save the output to the side, decompile it, recompile the decompilation output, run the recompiled executable, and check the output to see if actually the output of the running program was the same as the original one. To verify that actually our decompilation run produced not only compilable code, but also correct code that would kind of result in the same program as before. And those ones were the big issue for us, because back in the old days, with the old .NET framework, the executable is the executable. With .NET Core, the executable is a shim that is calling to bootstrap .NET runtime and then execute your DLL that sits to the side. So that's the exishim that's sitting to the side. And that exishim is actually framework 4x. So that was when our kind of, let's run the unit tests, fell flat on the face and said, okay, we can't do it that way anymore by actually kind of running the exi. We need to have something to run the crap. And in the end, we kind of built our own out-of-process runner that obviously, again, had to be separated between debug and release builds and kind of for the correct x86 or x64s. And we did that because we decided it's way more complicated to kind of build those runners, upload them to some artifact storage, and then pull them down, especially when you're testing locally. What happens if you have a point release of .NET? Then you don't have the correct runners in your artifact repository. So the cheapest way is to actually do this on the fly and run it on the fly. Speaking of running tests, we have a long history of running tests. And obviously, as you could already see, we are running the test with multiple frameworks. I don't know if you ever did that, running multiple tests in one CI pipeline. Turns out that kind of specifying DLL1 from framework X and DLL2 from framework Y and trying to run it in the same process is a big no-no. We kind of solved that issue for Avalon Edit, our text editor that's also being used in ILSpy, and we're using VS Test Console for this. However, this approach didn't work for us here, And kind of like we were done with our approach, and then Microsoft came along with the previous preview of 7.3, where it actually says we can now run different targeted assemblies. Like we were a tad too early, maybe it helps you for your projects that you now can do this, because that's a difference to .NET Test here. In this case, so DS Test Console can be a useful utility for you. Our more goodies. Our tests are not all .NET Core proper. Some of our tests, given that the project started in 2011, are rather old, and they sometimes depend on certain things. And in order to not reinvent the wheel, we kept them that way. So we have tests that don't run in this matrix of different frameworks, but actually only in one. This is the type system test that we have. And then there are some things that as a average .NET developer, you don't even spend a split second thinking about these attributes. You apply an attribute to a method and you're done with it. For us, we basically are looking at the attributes and go basically to the metadata tables and look up the attribute information over there. Funny thing, there are a couple of attributes that are compile time only, that don't exist in any assemblies. Just like as Marshall as. There is no information in the resulting assembly in there for us to go back to. So we are also using specialized code in here to kind of make it look smart when it's actually a dumb fall down in a case statement, because there is this information not present anywhere in anything. So yes, we moved the bulk of the tests to proper .NET Core, but as you can see, but I'm not yet done with testing. Test reporting. Our tests execute code. And GitHub kind of also found out that running somebody's code on your infrastructure is a bad idea. So for one, they changed that when someone makes a pull request, the maintainers have to approve the pull request for building, so that the pull request don't build before you say, okay, let's do it, because crypto miners, you name it, could be in that code package. So this also sort of applies to the test reports, because those could also have information in them. So we kind of dug around, no, Siegfried dug around to find something and kind of look at the date. So this was around the time we did the .NET 6 port, when we said we need proper error information, because the build logs with the XML TRX files are huge ass files. We need to do something differently about it. So we went and added the test reporter. Then we needed to change it and change it again, because there was a different package that was derived from it that was better. Then we found out again that if it's a PR, those files aren't there, you need to split it. So for security reasons, blah, God almighty. And then GitHub came along and provided the official solution to it. Yes, so kind of again, May, March, you see, we've just a couple of days too early doing this. And this is the summary action in case you ever need it, highly recommended to use. And this is how it looks now. Pretty nice, pretty great to look at. And this tells us immediately, especially in the case of PRs, where somebody is fixing on a small part, so we can easily find out, okay, what went wrong in this PR, and not dig through thousands of tests and find out in a textual way what went wrong. So nice formatting, this makes our lives much easier. It is highly recommended for basically everybody else that's doing this. So here's a laundry list. We are not cross-platform with our solution, because something is platform specific in our tests. We are using build packages that are actually only available for Windows. That might happen to you too. So kind of we are more or less proper cross-platform, but the tests aren't. Then one thing that threw us a curveball, we are writing registry entries for right-click open with. Turns out the executing assembly is not the exit, it's the DLL. Again, that thing with the stuff. So we needed to change that. So going to happen to you too in some point of it. With the new version, we dramatically increased the number of deliverables. Previously, we had a zip for kind of Xcopy deployment, and we had the MSIX. Now we have zip file deployment, we have the MSI, we have the Visual Studio extension, we have the pre-built one for x64, etc., etc. Guess what? Happened not once, but at least twice, that one of those bundles had not all files in them. So we now have a kind of a checking tool that checks is everything included in every package. Happened with the extensions, specifically, in our case. One shout out to one of the most important tools in tracking down a interesting, complicated, weird, strange build is the build log viewer, the structured build log viewer from Kirill. This is extremely important when you're doing bin logs. So we have one of our builds actually that's producing the bin log all the time. So we can see what process in which order, which target of MS build executed, etc., etc. Because that tripped us up more than once in our .NET 6 journey, because we are building NuGets so that depending on other NuGets, and our versioning strategy is an external update script that's written in PowerShell that we are using since the shop developed days, basically. So it's almost 15, 20 years old at this point. But we made a change to this file, an innocent change to this file, and then somebody came along and said, hey, your build process is no longer working. We were like, this is a PowerShell feature that has been in PowerShell, even PowerShell for Windows 5 for ages. Turns out, this person didn't even have PowerShell 5 on the machine. That's PowerShell 2. It took us some time to figure out what was going on there. So this is the joys when you're having a public project, that it's not a controlled environment, like in a company where you can say, okay, I can expect to at least have this kind of extension pack for Windows installed. No. Yes, this can happen too. But that was a surprise. Speaking of surprises, initially I talked about the things that didn't go so well. We now have multiple front ends that are using the decompilation engine, but would like to more efficiently reuse more advanced features of ILSpy, such as analyzers, search, you name it, assembly list loading, etc., etc. This was the RFC simplified NuGet package idea back in the day. We picked that up again to actually start doing it. And we kind of never really talked about it so far, because this is a work in progress, where we are kind of testing the waters to see what is possible, what can work, what won't work. We have kind of validated parts of it with the VS Code extension already, but still we aren't where we want it to be. Kind of an idea we have, and kind of gauge the idea, maybe you can tell us the ideas. We consider doing headless analysis. So you're not clicking around inside the ILSpy UI and kind of looking at stuff that you're interested in, like exploratory testing, but actually driving the entire engine of analyzers, etc., to say, and I want to compare the decompilation of assembly A to decompilation of assembly B. So to say it's version X, version Y, what has changed, kind of doing statistics on the stuff, to see, okay, how many methods do we have that are public? What sort of attributes are on those methods? Really doing analysis of this stuff. This is kind of what we are currently thinking about doing, making possible. This is one of those things that kind of we are mulling this week to be talking about. Speaking of under the radar, and I wanted to bring it on top of the table for everybody's attention, supply chain security. Finally, and luckily, this is also now a topic in the .NET community. Just yesterday, Microsoft's SBOM utility surfaced on GitHub. If you want to kind of find out what this is all about, you are going to salsa.dev. Salsa stands for Supply Chain Levels for Software Artifacts, which basically are 4 levels, kind of how far are you in your journey of securing your supply chain. And kind of interestingly enough, we started our journey quite some time back. So our GitHub organization is requiring two-factor authentication since early October 2019. So everybody going to our repos that must have two-factor authentication to make sure account stealing isn't so easy. Then next things is basically making sure that you have reproducible builds. So this is again harkens back basically to the decompilation engine. And who is a consumer for our decompilation engine? We want to provide sort of guarantees for them. That's why we are doing this. Basically, so we kind of have the standards in place for those build systems. That those are super easy to add to yours too. I totally recommend doing that. That's super easy. Another thing is that we do is code scanning with code QL on GitHub. It's super easy to set up, and the code rules run automatically against your code base and tell you if there's something in there from a known set of classes of vulnerabilities. Again, we do that especially for the compilation engine that's being used by others downstream. And finally, something that we started adding just recently is basically running on the entire ILSpy project, the Cyclone SBOM utility, to create the output that's necessary to actually import the SBOM into a reporting tool. And kind of when I'm talking all the time about the Decompiler engine being so important to everybody else, why on earth are we running it against the WPF frontend and not against the decompilation engine? The reason being, for the decompilation engine, we know exactly what third parties we include, Microsoft. So we know exactly what's in there. There's nothing in there that's in any sort of form interesting or complicated or dangerous even. So if you're doing it for more interesting stuff like ILSpy, that's interesting if you're running it in your corporation. So those are some of the things you can do. One thing we are not doing though is gate check-ins, because that would also be one thing. Don't let anybody push to master. That would also be one of those level requirements. That's what we don't do. We are too small a team to always do pull requests. We are mainly too lazy to do this every time. But yes, this would be also one of the things that you have a review before something goes into your software. That's also something. But please read it up on SalsaDev. And speaking of interesting websites in the supply chain security universe, depps.dev, also quite interesting. And yes, the grid packages are coming soon, which is basically kind of giving you an idea what do those packages that you are using depend on, giving you a good idea about your risk exposure by using third parties. So definitely something to keep an eye on and looking into this. Well, looking into this, what is a problem area we still have and we haven't addressed yet is signing. So we do code sign our executable as part of the Xcopy zip deployment. That's easy. So basically, I have a USB stick with the certificate and I download the artifact, sign it, and then kind of do the release, which is fine if you do release on a rather long cadence. It's perfectly okay if it's checklisted, so that was never a hiccup there. But ILSpy 8 has tons of things. We got an installer, so I would need to first sign ILSpy exe and then sign the installer. Same goes for the x64 standalone Xcopy deployment. That goes for the standard Xcopy deployment. So we now have a ton of those in there. So now doing the checklisted approach is still possible, but it's now nasty. So this is something that we are going to look into now for real to find a solution. And the thing is, for us here, basically means we need to be looking for a solution that can be easily copy-pasted. When that's kind of what we are talking about in terms of security, etc., it's kind of, we feel a responsibility to make sure that people don't start copying bad patterns from our code base. And the same goes for our GitHub actions. So when people go to our repo and think, okay, those guys are in the business for such a long time, what they are doing must be right, so that we are not adding something in here that's not right. Now, I put in 6.dev here for a reason. I'm doing my most of the day work in the cloud native and Kate's area. They do have a signing solution that's called CoSign, which works for containers, which is great in this area, but it's not a Windows code signing story. So that's sadly not working for us, but what is working, and is working for you guys too, is the later one, search for Git signing. This allows you to sign your Git commits and not be doing PGP crap. This is rather new, and is also one of the supply chain stuff thingies that you should be doing, because it's using an internal short-lived certificate per signing operation. You basically simplified version, sign in using OpenID, you get a short-lived signing certificate, you sign your commit, and off it goes. It's now super painless, and that's one of the things that you can do. Stuff that doesn't really apply to us, but that applies to you as the .NET developers in general. Those are features that are new in 17.2 basically. That's central package management and locking package sources. Central package management even would be interesting for us in ILSpy. We are doing a simplified manual version of this, where we basically have a props file where we say if somebody uses a unit, then that's the version. And then we kind of transfer the version string that way into our projects. And central package management is now an official NuGet feature to be doing that. What's way more interesting is logging package sources. Again, much less for us, but very important. When you have internal NuGet packages, then you can say if a package is imported with prefix X, then only pull it from this source. Because there was just recently a small brouhaha in Germany. I don't remember which package repo they were kind of tricking, but they basically published an internal package with the internal name on a public repo. And by resolution, the public repo was queried first, and that way the fake package was included in the build process. So that's the kind of attack vector this package locking is actually protecting, and that's super interesting for enterprises that have their own NuGet package sources. For us, again, because we are mostly on the Microsoft and NuGet.org anyways, except for the odd debug thing that we have, but yes, this is kind of an interesting thing, and those are the things that we kind of always discuss in chat. Yes, we're using Skype. We are old enough to still be using Skype for this. And we try to not bury this stuff in Skype at all, if possible, and at some point surface this information and talk about this information. So kind of, we started our developer meetings because we were fully remote. So we had Sharp Develop that started in 2001. We rather quickly had in-person meetings, simply because everybody on the team was non-native English speakers, basically. Everybody kind of had email or chat with the people. They had never seen those people. They didn't know whether that email that was written in bad English was an attack or bad English. And so kind of to introduce everybody and get everybody to know each other so that they know, oh, he didn't mean it that way. He just isn't as versed in English as the other guys is. So, okay, we cut him some slack. So he's a person that kind of is circuitous in the discussion, takes a long time, or the other one is to the point immediately and being bored or pissed off. So kind of getting to know everybody. I think most of you in the past 2 years kind of had those problems now. We had them from the get-go of our open source project, and so we kind of had this kind of rules sheet here to say, okay, what's being discussed in what setting and why. So face-to-face for us is really mostly intended to be to slow down the discussion. Because when you're in the chat, somebody writes an argument, and while the other people are thinking about the argument that the person brought, that person is already writing the second one. So you're kind of always lagging behind in the discussion. There's no real discussion going on. So that's what the face-to-face discussion makes way easier. It can't be properly replaced by a call, I would say. Calls are great for doing a thing right, but not doing the right thing. And what I mean by this is, again, this discussion of what is the strategic direction. When it's about a tactical problem, where you say, we need to solve bug X, Y, Z, then a call for doing the thing right is a proper course of action. Otherwise, it isn't. So that's what you can get from our experience. To kind of short-circuit one question you might be having, what are we going to discuss this week? So our official meeting starts tomorrow, runs till Sunday noon. What are we going to discuss? We are going to look at basically our issue list. So you can call it backlog if you want to. We have a couple of stuff in there, and we basically are going to look at it in two ways. One way is going to be, okay, what's external facing? So the features that you see pop up in the UI, like duck mode, baby bookmarks, because that's not being done yet, so kind of picking one of those lists. And kind of looking, okay, from different angles. So the product management angle, basically, okay, how many users would benefit from this feature? Then stack rank it by a different way. How complicated are those features in relation to each other? And kind of what would be interesting to us. Because what wins in the end still is something that is of value to us. So kind of that is what we're doing. And then the second sort of list we have is internal facing. You call it usually technical debt. Something like how can we improve our pipelines to support future language features? How can we go about stuff now that we know to do it differently? So also the same thing, ranking it by different criteria. So this is what we are basically going to do, because again, as I said, a call is perfectly fine implementing this stuff. But having an open-ended discussion on how to actually do it and what options we see in doing it is best done face-to-face. So this is basically what we're doing here. And to be brutally honest, in the end, what wins every single time is C# language features. So when there is one thing that we do all the time, constantly, if you look at our commits, is new language features. You will see one or two end-user facing new features per major release version. But what you see is a constant drip of language features, because that's bread and butter for us, our decompilation engine, because we are upstream of so many other projects that need a perfectly running decompilation engine. So that's why this is always the main issue. And our main issue is 829, if you need to remember any number. This is the issue that is tracking our progress with the language features. And usually we are pretty conservative with implementing language features. However, with C#11, we were too quick once. We decided, hey, this feature from a decompiler's point of view is super easy to implement. Like a day or 2 days later, the feature was dropped. What I want to say with that is we are usually very conservative when it comes to picking of language features. And with that, I'm going to hand it over to Siegfried, who is going to take you through a bit of the C#11 features that are upcoming. To give you an idea, if you haven't seen any of those yet, just a brief overview, and then looking at those features from the decompiler's view. Okay, how complicated is this actually to reverse to proper C# code again? And with that, I'm going to hand it over to you, and not dropping my glasses, hopefully.
Yeah. I'm now going through a few points on our decompilation engine and also language features of C# next. I'm explicitly not saying or calling it C# 11 because you never know what's going to be there until it's there. And later we'll take a look at your questions you already posted, and of course the things you want to ask here live or in the chat. Yeah, C# from a decompiler's point of view is basically there are different kinds of features. For one, there are the irreversible features. So basically, all the things that are made or compiled into metadata and are constant. So name-off is one of these features that we cannot magically kind of reverse, because what's there in the binary is one string, and we could do some guessing if name-off was used in some cases, but it's not generally possible. And the same goes for constant expressions. They're all kind of baked into the binary, so we can do some smart guessing if it's if it's pi over 2 or some other expression, but it's just guessing. Other features are partially in metadata, like tuples or dynamic or even the NRT context. Those are features that can be partially in method signatures. We can reverse those features, and kind of if there were some tuple element names, for example, we can add those information in the decompiled code, but not so for local signatures and local variables, because those cannot have attributes. So for many features, we have to do some guesswork to make the code look nice. And the third category are the almost full fidelity features, like async wait state machines and yield return state machines. Those are, if you know the pattern, you can quite easily reconstruct every statement in the original code. Also, easy patterns are like log statements and using statements, and also for each are very easy to kind of reconstruct. Now I want to give you a bird's eye view of C# next, and as you can see, there are some features I have crossed out, and those are features which are not, which we cannot exactly or won't support because they are more like convenience features. For example, new lines in string interpolations are not something we want to bother with in decompilation. Also, we don't care about the relaxed ordering of ref and partial modifiers because, yeah, we have one single setting that we use when pretty printing the code, but we don't, we have not many options with when it comes to pretty printing code. Things like name-off, we don't care about, or we cannot reverse it. That's why it's also crossed out. And one feature are generic attributes, which of course we will support and we partially already support, but there is an open issue with the .NET Runtime team, because we're using system reflection metadata for reading and extracting all the metadata information from .NET PE images, and it turns out the C# compiler, so Roslyn, is able to emit generic attributes, but one of the libraries used in the .NET ecosystem if you want to inspect PE or .NET PE images, is unable to handle them properly, and you get a nasty bad image format exception if you try to kind of decode a attribute signature that contains a generic attribute. Not in all cases, but in some. Okay. One feature that's actually kind of easy to implement from a decompiler's point of view is the auto default structs feature, because that's a feature that's only you can see it here down in 17.3 preview 1 auto default structs, which is basically only lifting a restriction imposed by the C# specification, by the C# compiler, which so if you use the feature or if you don't, it doesn't matter, because the output, the generated IL code, is always the same. So it's something we don't need to support, because we actually, of course, we could do some guessing if the feature was used or not, but yeah, it's basically we get that feature for free, I would say, by not supporting it. And of course, one feature that's very interesting from a decompiler's perspective is also the ref fields feature coming up in the preview 3. I think from the complexity point of view, it's very complex, because there are some aspects like it's called the scoped modifier you can use on local variables and parameters, and especially for local variables, we would have to do some inference whether this feature was used, and turns out the rules of ref fields are very complicated, and like with the nullable reference types feature, we will probably only support a minimum set of features and only add specialized support for edge cases later on. And now I want to show you how one feature is how we go about implementing, or how we look at language features, namely the required properties feature, which is coming up, or was added in 17.3 preview 2, I think. And of course, here I have one simple example of a required property, and on the right side I have the the code augmented with the compiler-generated attributes, and I will switch over to Shuffle for that, which is also a site where you can try out lots of features currently in development, and you can use C#, Vision Basic, F#, and IL as input languages, and you can see that you can get results for decompilation in C# and IL, which is powered by our by the ILSpy Decompiler library and IL disassembly library. And there is also the feature that you can look at JIT ASM for if you are really interested in what machine code is generated by the just-in-time compiler. You can also do inspection of the syntax tree, or just check if the decompilation is successful or not, or some explain feature I don't know much about. And of course, you can just run the code if you want to try out or show that some behavior of the some generated code is wrong. I've seen Sharpnut used often by people reporting bugs in Roslyn, because it's really nice to showcase to give a working example when there is a bug. And we have this required property here, and this is the generated code. And here we see the compiler generated backing field for the auto property, which which is a pattern we also detect and kind of remove the backing field declaration and collapse the getter and setter bodies. And for us to kind of reverse this feature, we would do the following. We would look at the types, and if the type has a required member attribute, then we would look at each property and check if there is a required member attribute, and simply remove the attribute and add in the required modifier. And in the end, we would just hide the compiler-generated constructors, and yeah, that's how we do it. So it's very simple. So I think okay, done.
Now, mind you, not every feature is as simple as that. I just want to point that out. We intentionally picked the simplest one we could find, so it actually would fit on a single page here. So that was the intention of this here. So no, not all the features are as easy as this feature here. And we have kind of varying complexity of features done in the history of ILSpy. By the way, can you switch to the discussion of that? Because we're now drifting over into the Ask Me Anything parts. So we're going to switch around between online questions here in the room, and maybe if there are questions anywhere in the online streams, you're going to tell me if there is none yet. So I'm going to do all the softball questions, which means I'm going to do the first one, history of ILSpy. So the super brief history of time. It started out in 2011, the famous brouhaha about the Reflector project going paid. We back then in the day were doing the sharp developed IDE, and one of our developers, David Spetsky, by any sort of stupid luck, was building a decompilation engine as part of his PhD thesis. And he kind of came and said, hey guys, you know what? I have a decompilation engine. We basically took it and kind of built a crappy UI around it and shipped it. That's how the whole thing started. Can you switch to the release history, please? Okay. Because that gives a bit of an idea. Yeah, the release history. And scroll to the very first one. So you can see where we actually got started here. And then we kind of improved, up to the point where okay, the architecture doesn't fit our needs anymore. Because our goal always was to provide a decompilation engine that creates syntactically, semantically correct code that can be compiled again. And we had a couple of magic conversions in there. Let's put it this way. So we had to rebuild the entire thing. And maybe at some point you will see on the right-hand side the new decompiler branch over here. That was the first big rewrite of ILSpy. And that took considerable. Let's be nice about it. Yeah, that was enormously complex doing this guy. Now, once that was done, tons of new features were added, kind of added on top of it again, Then the interesting part from December 2017 session in here, where we actually kind of went that standard, and then Microsoft kind of experimentally included us in Roswell. Back at this point in time, we were using monosession for metadata reading. And turns out Microsoft wasn't too keen on pulling in yet another huge SDLL into their processes, just because the compiler is using that. So they kindly, more or less, asked passively, could you maybe switch to system reflection metadata? That was the next big rewrite. of the whole story. And that also kind of give you an idea was the point where we stopped reading well-formed assemblies. Because the SRM tools more or less don't deal with obfuscated code, only to the point where it's at least readable for the tooling. Because SRM is used by Microsoft tooling for various products, and they don't really care about well-formed stuff that the runtime is capable of executing. So that was when the problem started for us in terms of not being able to read obfuscated assemblies. And also a nice tidbit from the history is we actually had a debugger. So there was a debugger in ILSpy that was borrowed from Sharp Developer and kind of hacked into ILSpy in a way that the code bases couldn't be easily kept up in sync. So at some point then we decided, okay, we are using the engine, which is nicely packaged inside the IDE, to be able to step into DLLs where we don't have the code for Decompiler. Enter Visual Studio version current, where this feature has appeared again, where you can actually step into a code that we don't have debug information for. So that's our decompilation engine with our PDB generation. So we are now back at the feature that we had 10 years ago, basically. But now in a product that is being used by millions, which is a better deal for us, because it's now being used by basically everybody. So that's also kind of history lessons of, yeah, in the meantime, it was bad that we didn't have it, but we were at some point also glad that we didn't have it, because certain people in the reversing community chose a different product. They didn't go for ILSpy, so we didn't get so many requests for properly cracking other people's code. So we are very happy that we don't have that sort of community on our issue forums, or that is somebody else is doing that. So we're quite happy for that. Other than that, those were the major points. Maybe again to harken back to what I said about one or two features were released at the dark mode. The dark mode would have never happened had not somebody contributed. So thank you for the contribution. At this point again, we simply wouldn't have kind of prioritized anywhere near doing it in this century. To be totally honest about that. So do we have any other major touch points in there? I don't think those were the major ones.
Yeah, maybe the tapped UI, but
yeah, those are minor things. Yeah, there's tons of stuff that happened for non-obvious reasons. Just like the reason why we didn't really go for dark mode, but kept our UI, because it's super easy when somebody posts something on Twitter, we immediately know they will be using ILSpy because of the yellow background of our text editor. So that's our branding, unintentional branding, although, but it is a branding decision that actually happened. So to do that. Okay, that's it. It's enough on history. Do we pick a question from the audience then?
Yeah, from a live audience. Fabian.
Sure. Yeah. First, before I ask the first question, just as you know, I work for Sign Power, and you mentioned a lot of full-time problems before, and I think we can have a good solve because we have a free platform source project, so it's fine.
I'm very well aware of that. It's one of the options we're exploring actually.
Yeah, because we can do the deep signing and we can do ESI signing and fluid signing. But my question is something else. Earlier you mentioned that you have a very large test matrix with different sharp and so on, and you also have different frameworks. And I want to know if this pays off. If you really have your tests. If your tests running on a different type of framework, do you find bugs? If you really find bugs in the code?
Okay, so the question was, is it really necessary to have this huge vast test matrix with different frameworks, different compilers, and why on earth might this pay off? So before handing off to Siegfried for this specific one, secret glossed over the state machines for async and wait. You have no idea how many times on point releases of Roslyn those state machines have changed. That's just Roslyn point releases where those state machines have changed. But for details, I'll hand it to you.
Okay, so yeah, to answer your question in short, in one word, yes, it's necessary to have such a detailed test matrix because, yeah, we always find bugs, especially when we add a new version of Roslyn to our test matrix. We find that patterns have changed, that in some cases the newer C# compiler is reusing, is using more local variables or less, and we always have to adjust the patterns, and we want to make sure that if there is one feature we implement, we want it to work with all the different versions of C#, especially if you, when you think about the switch on string feature, there are like, I think, 4 or 5 different ways the compiler changed its pattern it uses. In C#1, it was based on a hash table. In C#2, it's based on a generic dictionary. And in later versions, especially in Roslyn, they are now using a compiler-generated hash function. And yeah, the patterns always changed and are optimized. And we want to make sure that we support old code and new code alike. And especially when you think about that we also support the mono C# compiler, which has its quirks. We definitely need this broad test matrix. Yeah.
Okay. My question also was about the target fragment, because I think there was one test against 4 and 6, right?
Yeah.
And does this also different things you have to consider?
Yeah, because especially when you think about the string interpolation feature, there are now optimizations which are only included in the newer .NET frameworks using the there is some specialized type. I forgot the name. I think. And in the classic framework, they are still using the string.format method, and it's just syntactic sugar for the string.format method call. But in the newer editions of the .NET framework, of .NET, they are using specialized string builders. And if if a new version of Roslyn can't find this special type, it will fall back to emitting the old string.format call. That's why we had to include both the old and the new version of .NET to find out these, or to make sure that both patterns work.
Yeah, just to add, we have tons of code samples included in our unit tests that come from customer bug reports that are kind of some edge patterns that happen in like some weird in-between version. We are especially big friends of the MCS compiler that really did some strange things there. Siggy was touching on the sort of optimizations. So when you are at runtime, you have a release build, and you're running that stuff. You have a lot of variables that are in registers instead of actually being on the stack. So there's also all sorts of interesting things going on when you have a debug build or an optimized release build. So this makes a huge difference in the quality of the code we can generate, depending on the information that's available, more or less. Can you switch back to? No. What was it? Tough. Okay, that's one for you again. Yeah.
Yes. Yeah. As for toughest and easiest language feature, I'll go with the easiest first because I have a lot of things to say about the toughest one. So the easiest, I think, yeah, those are the features that you don't have to implement because, yeah, that's the easy feature. That's the easy features. It is the ones you don't have to implement because, like I previously told you about the auto default structs. That's something we can't, or of course we could try to reverse it, but yeah, it doesn't. I think it's not top priority. And for the toughest, I would say, yeah, there are many tough ones. For example, I'm not sure how many of you know that we're not using kind of, in order to make sure, you know, when you decompile something in the IL code, there is exactly specified which method to call. There is the declaring type, the return, the method name, all the parameters are spelled out exactly. And when converting it back to C#, you have to do what the C# compiler does, namely overall resolution, to kind of find out are there other methods we could call if we kind of, yeah, we want to make sure to reduce the number of casts to make it look nice, but also we want to emit correct code because that's one of the biggest problems the old decompiler in ILSpy 2 and had was that it was doing a lot of guesswork when it came to conversions. And in order to kind of properly handle conversions and overall resolution and member lookup and all these crazy things, you have to kind of re-implement the compiler. And if we hadn't previously created something like Roslyn, namely nRefactory, which is way older than Roslyn, and was used in Sharp Develop and also in Monody Develop, the last edition of nRefactory, which was in development in 2011, was developed in a joint cooperation with the Monody Develop team. And in that project, we were kind of re-implementing the C# specifications as closely as possible. And with all the tools from that project, we were able to kind of re-implement the decompiler using correct semantic analysis. And then we were able to make sure that the code we produce is correct when recompiled. So correctness tests are a big and major thing we have to do. Yeah, and so the toughest feature is, from a compiler writer's point of view, the toughest feature was actually that we kind of get these basics correct. But thankfully that was made easy because we already had the nRefactory library to do that. And so to answer the question now, the toughest feature I think was the async and yield return state machines, because looking back at them, it looks easy, but we had to do a lot of reversing to kind of get the behavior correct and understand the different patterns that are employed by the C# compiler to produce these state machines. And yeah, especially exception handling in asynchronous code is a difficult topic, and we wanted to get that right. So that's a tough feature. And also the nullable reference types is a very complex thing. We now only have limited support for it, namely we only use the information embedded by the C# compiler in metadata attributes, and we don't do lots of inference of nullability inside method bodies because there is no special information available.
Any other questions?
What way does ILSpy differ from other compilers?
So the question basically is around how do we compare to other products in the field of decompilation in the .NET arena. I kind of gave a couple of hints where we are going and what our main focus is. Our main focus is really about being the best decompilation engine, quality-wise, that is to be available. So, yes, we are totally neglecting the user interface in that respect, because that's not our #1 selling item. Our #1 selling item is the reusability of our compilation engine for other third parties. So making sure that the stuff we build is correct, is safe, can be easily plugged into other systems. So, like I said, it'll be used in Visual Studio, in OmniShop, Roslyn for Visual Studio Code, and others that are using it in there. It's used in LinkPad, and many other products are using it actually these days. So, just one of the recent issues was from the debugger team on the Visual Studio team when we are going to cut in the release of our engine because they need the changes that are in the most recent bits. So we kind of accepted our position as being a part of the infrastructure layer and not something shiny that every developer sees every day and knows it is ILSpy. But I will tell you, without the F12 go to decompiled sources features, I wouldn't stand a day in Visual Studio because I needed so often to go to decompiled sources of assemblies that don't yet have the sources published on Nuget.org or are actually internal and have nothing published at all, or don't have any of those things. So go to decompiled sources is a killer feature for me, myself. So I am perfectly content being in the infrastructure layer of the ecosystem, but being basically used by millions of developers. It's just like mutants of JSON isn't really sexy in itself anyways, but everybody needs it, everybody uses it without much thinking. And ours is even more removed in terms of you don't even know it's there. It simply works when you have F12 in Visual Studio. So to come back to the question, how do we compare to our products? Not really, because all the other products are either commercial closed source, which is different from what we do, and kind of sometimes interesting to see for us is when we implement a new feature that certain other products very soon after have exactly the same feature. We've seen that happen a couple times. So we are beating the path in certain areas, and our area definitely is our #1 main focus area, the decompilation engine. Being the best one out there is what we are. Other questions? Yeah.
When implementing a new feature, you have to know all the details of the feature. How do you gain information about this? Do you reverse engineering, or do you have any connections to the velocity?
That is a touchy question. I am going to pass it on to our specialist who knows about all the great specification documents that Microsoft is putting out in terms of language features.
So, you know, there is this C# language repository on GitHub, and there are lots of discussions going on. I'm not going to comment on this because I have my own opinion. And I would love to have a finalized specification for C# 6. Now we're at C# what? 11? Yeah. So when implementing new features, we try First, we tried to read the specification they put into the C# language repository. But in most of the time, we end up producing lots of example code, which we then use in our unit tests. And we infer all the possible combinations and patterns from our samples. So basically, the Roslyn compiler is the specification, not the other way around. Yeah.
And if you have some specific, very simple questions, do you just ask one in the GitHub repo, or do you have a connection to the Roslyn guy?
We have no special connection, but if we find some oddities in the way code is generated, or if there are some behavioral changes, like the auto execution changes when you use this language feature, or if it doesn't work at all. There have been cases where there is a feature which doesn't work. I think it was the not pattern which didn't work. It didn't work. And they only patched it later in some point release of the Visual Studio, and yeah. So we use the official channels to ask questions and report bugs. That's what we do a lot, and yeah, we have got great responses from the Roslyn team and also from the runtime team sometimes. And yeah, I would say no special connections needed. They are very responsive and friendly.
And just to go back to the specifications, the documentations you find are mostly design documents and not the final implementations. That's basically when you've been reading between the lines of what Sigurd has been saying is, those are the wish list documents. Oh, I'm going to build this feature. How cool is it going to be? But those documents are not being updated usually once the feature has been implemented. So those things kind of reflect the state during design time, but not during kind of implementation and once it's in production. So yes, that's why having a fully specified language documenting the actual behavior of the actual implementation would be super nice. They started to work on that, but they're still way, way behind on the current versions. And kind of, it's problematic because these days, behaviors do change between versions. That's the added downside of documenting all this, and that's why we have the heterogeneous test matrix, because the patterns do change. Okay, any more questions?
I have.
Good.
When Visual Studio decided to include ILSpy, some history, what happened? Did they ask you? Did you need to adjust some things in ILSpy that this would happen? Or were you surprised by the release notes from Visual Studio?
No, that was basically Sam Harwell that helped us port to .NET Standard and the modern project system. He's working on the Roslyn team, and he kind of then maybe more or less himself decided that this might be a good feature for Roslyn and proposed it internally. But this wasn't something that we proposed to the Roslyn team. Hey, we have a decompilation engine, wouldn't it be cool if you included it over there? That's something that came out of the Roslyn team. And yes, we then worked with them to make sure that the decompilation results are getting better. I will say that our standalone executable is producing better results than inside of Visual Studio. The way Visual Studio is kind of dealing with its project system, we are not getting all the full fidelity metadata assemblies that we would need to create the best code. So this is still something up in the air to be improved. So yes, the results could be better, but they are already loads better because a more recent version of the decompilation engine is now in Visual Studio. So if you have 12 and you are getting a decompilation, there is actually information on top of the file about the version of ILSpy that's being used. And down below in the file, you get a long list of assemblies that have been sent to the decompilation engine to generate the output. So you get an actual idea what was fed to the decompilation engine. So you can kind of take an educated guess why the result might be different from a standalone engine that has a lot more information available to it. Any takers for the last question?
When you decided to put like ILSpy into Visual Studio, did you kind of donate something or just like take it for granted?
When they put it in Roslyn, no, they simply kind of used it. And that's precisely the idea. So they are a good citizen in open source, at least when it comes to dealings with us. So we had a couple of calls, especially with the debugger team, as they were working on the PDB generation feature that we have in the tooling. Time and again, they open up issues. So one of the most important things you can do when you're using our tool is report something that doesn't work with something that we can use to reproduce on our end and actually make it better. So we really are one of those classical open source projects with no kind of commercial side hustle. It's really a spare time open source project scratching our own itch basically. And that's why I was so expressly hinting at we like building the decompilation engine. The UI is not really something that we are so much into. So if somebody comes along and implements one of the help wanted features, yes, thank you very much if you want to do that, simply because we are stretched thin already building the decompilation engine and making it work great. And that's actually the one thing that we like doing best. And that's why we think we are the best in this one, because we concentrate on this very specific part of our project. Okay. Good. With that, thank you, and I will hand it over to the organizer to do the outro.
Yes, so we need to change of everything again. Now, has already broken. Yeah, PowerPoint. So, start with from for the screen. Yes. Good. Let's make it quick. On reset, where's mine? That doesn't work. Yes. Good. Thank you. Every hour speakers, I don't know how much you need. Every one of our speakers gets a custom coaster with our logo. So I have some, so should be enough for you too. Thank you all for joining here and on the street. Thanks again to our sponsors, Rubicon for the location, for the food and drinks, and for the financial support, and also here to Everett, and JetBrains for the 12 months license that we will wrap afterwards. Quick, if you also want to host a meetup,
please get in touch with one of us three. We're always looking for locations. Because, yeah, our next schedule is a lot of to be defined. We are working on it, so yeah, best thing is meetup.com, joining, and then you get notifications when we have the next one. Please spread the word that we're doing these events also now again in person, and more people we are here, it's more fun. Again, a lot of QR codes you probably don't know. And the biggest interesting one is we always want to improve our meetups. So there is a quick feedback form. If you could give us feedback, that would be helpful for us to improve the next meetups. And with that, thank you, and everyone have a nice evening.